Welcome to TechTalks, the podcast where we delve into how technology is shaping our future. For new listeners, I'm Linda Ekwall, your host, and today you're in for a treat. Have you ever wondered how things are put together and disassembled? And did you know that cutting-edge tech is transforming the way we build and create? Together with our experts here, we will uncover the hidden tech in assembly processes. This isn't just about nuts and bolts, it's about the shift that's enhancing efficiency, boosting quality, and paving the way for a sustainable future. Get ready to be inspired as we explore the future of assembly technology. With me here today, I have three experts. So let me introduce Robert Karlsson, Platform Software Manager. We have David Lindblom, Global Business Manager for Aerospace. And we have Per Heyser, Team Leader and Coordinator Manager for Special Projects. Welcome. So let's start with the first question then. So Robert, why would you say assembling is crucial for things to function seamlessly?
In the division that me and David works in, we work mainly with bolted assembly, with joints and so on. And this is one of these technologies that's been around for a long time. And it's kind of invisible. We don't think about it in daily life, but we have screws and bolts and nuts in almost everything we use. And it is a very good technology in the aspect of it. You can make a very secure and tight connection, but you can also disassemble it. So it's very good if you need to repair things. And when you manufacture things, of course, putting things together can be different materials, can be different geometries that don't fit well together unless, or you can't really cast them in a good way and so on. So you have to put them together somehow. And their bolted assembly is a really good way to do it and also make a very secure connection, I would say. Yeah.
Yeah. And I also think there's many different challenges which are really cool when it comes to bolted joints. So we start working with customers like in electronics segment that do mobile phones, for example. And in a mobile phone, you have roughly 50 screws. And those screws are extremely small. You can hardly see them. And finding an assembly method for screws that small while keeping a high pace on the production line, it's a huge challenge to be able to do that in an effective way. On the other hand of the spectrum, we have windmills, for example, where you have huge bolts. And all of the final assembly is done out in the field as well. And that poses different challenges because, I mean, if a windmill were to break down or something like that, that's more or less a catastrophic failure. So then we need to have ways of securing that also out in the field. So I think overall, the different challenges you see within assembly and especially within final assembly is really quite remarkable in some cases.
My perspective is more for the automotive industry. So joining is crucial for the functionality of many products. And we need to reduce the weight of our cars. And therefore, we have to use materials with a really high lightweight potential. For example, aluminium or high-strength steels. And it's really complicated to join those materials together. And we are working on different joining technology. For example, we use adhesive joining technology. So you have different metallic components. They have to be joined together. But if you think about adhesive joining, there's one big disadvantage because it needs a lot of time and heat to be cured. And therefore, we have some additional joining technology. So it's called hybrid joining. So at first, you apply the adhesive, then you put the components together. And as a fixation technique, you use this mechanical joint, and then both components are joined together, and then they have enough time that the adhesive can cure. So there's a really big advantage that we offer both technologies.
Yeah. No, I think it's quite interesting to see this, that, I mean, really, we work with technologies which almost everyone has some relation to, whether you assembled a furniture from IKEA or, as you said, maybe you made a hobby project and you used the glue and so on. But then when you take it to these extreme productivity demands, safety demands, quality demands and so on, becomes highly complicated, right?
Yeah, and for example, you just mentioned the safety aspect. So if we talk about adhesive, that's high-tech products, and they're really important for a modern car because they are not only for crash safety but also for driving comfort. And the idea to reduce weight is really important because that's the way how to reduce CO2 emissions, and therefore sustainability is also a really important topic in this joining technology.
Absolutely.
What are the latest innovations then in assembly, Per, and how do they improve efficiency and quality, would you say?
In a traditional car, you have a lot of stamped components. So you can join them, you can weld them together. So it's sheet metal parts. Right now, there's one big trend going on in the automotive industry. So a lot of companies try to investigate these large-scale casting. So they are called giga or mega casting. And if we talk about mega casting, you have really large components. So half of the rear end of a car is built out of one component. So more than 50 small components can be put into one part. So this is a real big change. And casting is the process. You have melted material. You put this melted material into a tool, into a special design. There's a lot of heat inside, and it has to cool down. And at this step of cooling down, that's the point where the cracks start. And cracks are not allowed in the automotive industry. So it's really complicated to join those mega castings. And it is possible to join them with conventional joining technology, but then it's necessary to do a heat treatment. So you need a lot of heat, a lot of energy, so nobody wants to do that. So therefore, my colleagues in the United Kingdom, they invented a special screw just for joining mega casting with other materials. One additional point which I would like to point out, because it's a screw, it's removable. So from the perspective of sustainability, recycle and reuse, it is possible to unscrew and disassemble the screw. So this is also one major advantage. And right now, this is the only joining technology in the market to join mega casting with other materials without any heat treatment.
Yeah, we see this mega casting trend as well. It's putting ripples all through the factory, since our products are more on the final assembly lines and so on. But here we see things like this unboxed concept, which is essentially a new way, since you can make larger structures and larger parts and so on. You can also put them together in a different way on the final assembly line, which is changing quite a lot what we see as well. And it's also helping to drive this trend of further automation, so more robots also in the final assembly line. I think on most car lines, some parts have been highly automated for a long time, like the welding and things like this, adhesive side as well, of course. But when on the final assembly line, where there's a lot more cramped spaces to go into, and a lot of parts going together. There's not been so high automation so far, but with new advances now, both on this giga casting and how the parts and how you can put the car together, but also in terms of robotics, right, where we have now cobots and other technologies there, which is starting to automate also the final assembly lines.
And then you have to explain what's a cobot.
A cobot is essentially it's a type of robot that is designed to be able to work more freely. If you take a traditional industrial robot, you have to have huge safety cages around it and so on. The cobots have technologies which mean that they can work quite close to people, essentially.
Almost side by side.
Yeah.
Mm-hmm. But they don't look like humans. They are still robot arms.
They're still robot arms so far, yes.
So how does the integration of AI and data analytics enhance the assembly process, Robert? And what are the future advancements that you see?
I think I have to start and go back a little bit to why do you even want to collect data from putting things together, right? And it is a lot about having a record of the quality. That was the initial thing, and our products have been generating and storing data from the tightening processes for over 20 years. So we have a long history in that. But the latest advances now is both that we can now send much more data, so we can get much more information about the process, and that data can also be analyzed. Before it was more manual. You used some, of course, algorithms and so on. Then came machine learning, and now we have advances with generative AI, which is really exciting, where I think it's still an emergent field. It's not quite clear exactly how it can be used and so on. And personally, I think it will be more used maybe on automating things like setup and connecting things together and so on, rather than actually be used to analyze the data itself. But coming back to the data, for every tightening then that our tool does, it records and sends around 4,200 data points, I think, and that then is something that we send up, and we have products that are using then machine learning algorithms, so AI, to take a look at that signature of that tightening, and if there's a trend, or if it thinks that something is wrong in that tightening, it's very accurate on actually labeling what went wrong. And if we know what went wrong, we can also then give advice back to say, okay, you have a problem here. It might be a problem with the screw, it might be a problem with the part, or it might be, of course, be an operator mistake. So then we can help then the people on the assembly line to correct that in real time, which is a really big thing for both quality and keeping the line flowing.
But if you then look at AI-generated data, would you say it can be trusted?
I think so far it's all about accuracy, right? And if I look at, for instance, the model I just talked about, it's very, very accurate on labeling what went wrong, or if something went wrong or not, right? Is it 100%? No, it's not. But it's one of these cases where being 85% accurate is much better than having nothing at all.
Yeah.
So that's usually the case. And I think this is also what we'll see. I think it's a little bit more tricky when it comes to these new language models, generative AI and so on, where it actually gives you something which looks very trustworthy, and it's words, it's not just numbers or labels, right? There I think it's a little bit more tricky, but I think we see so fast advancement in that area, so it's just a matter of time, and within shortly I think that problem will be solved as well.
I think it goes pretty much throughout that everyone who's working in an assembly plant has responsibility for processes within assembly, are always looking to make improvements, and AI will be able to provide those kinds of recommendations that they need, and be able to help them with finding the opportunities for actually doing the improvements that they're trying to achieve overall. So I think there you have a huge potential overall. And then, of course, at some point, humans will have to be involved making the decisions and seeing what is rational to do. But with that said, the progress is so quick right now. So over time, we will start seeing real improvements coming from AI-generated data.
Yeah. No, and I think that's an important point, because we talked about automation before, and usually when we talk about automation, we think about robots and these things and so on. But I think a clear trend that I see right now, thanks to both AI technology and also that it's much easier to transfer and share data, I would say, is process automation. So making the planning processes and connecting to suppliers, getting things into the factory and so on. There's a huge movement there on making that a lot more efficient. And that's also where I think AI can make a big difference.
So, David, could you share some real-life examples of how this assembly technology has helped companies to reduce their environmental footprint and promote sustainability?
If we look at assembly in general, or maybe even final assembly, and I mean our customers' product overall, the main thing that we can achieve and support our customers with sustainability is being able to support them with creating a better end product. And with better end product, it usually means reducing weight in different ways, because that's the main contribution we can do. And I work a lot with aircraft, and that's basically the main thing of being able to be more sustainable is reducing weight. Same goes for the motor vehicle industry with a car, for example. If you can use smaller bolts, if you can be more efficient with weight, you will have a more sustainable product in the end. And that's the biggest contribution that we can do. And on the bolting side, we try to do it by supporting our customers with choosing the right bolts. Usually you can go down in bolt sizes and keeping the strength. And if you adapt your tightening strategies as well, then you get a really good starting point when it comes to reducing weight, because the amount of bolts you have on a car can be quite significant in terms of the overall weight of the car. So that's one of the main contributions we can do. Then on top of that, we know that our products can also be more sustainable overall. So if we look at our products and the footprints our products have, it's mainly when they're used in operations that we see that they are having the biggest impact on sustainability overall. So of course, what we try to do with our products is to make sure that we use as less power we can to start with. But then, of course, we do see a big improvement when we go from example, air tools to electric tools, that we can reduce the amount of power that is needed to use our tools overall. So I think those are kind of the two perspectives, how our products are used, but also how our end customers' products are being used. And then on top of that, I know there are specific things when it comes to, for example, what we already talked about regarding gigacasting, where we can make contributions as well to support our customers to be able to use those kinds of technologies also.
Is there a shift you see to battery-driven tools?
Yeah, so I think that is also related to sustainability, but I think in that perspective is even more related to flexibility. So on an assembly line or on a modern assembly lines, you just don't have one variant of a product. You have multiple different variants. And you have many challenges regarding this. It could be regarding accessibility, so being able to access a joint. If you have a battery tool, you typically get more flexibility in terms of being able to access joints, for example. So mostly that. But when it comes to the tool you choose, it's more optimized for the type of application that you're trying to achieve. So the biggest benefit is when you go from an air tool to an electric tool overall.
But on these assembly lines, I guess we are not the only supplier there, right? So you also work together closely with other suppliers, or is it together with the customer? How does it work to set up a full assembly line for a production of a car or something else?
There are many technologies on the assembly line, right? And there are what's called machine tool builders involved, and these are companies that are specialized in building assembly lines and so on. And then there's a bunch of technologies going into that, and how we contribute into that process is, of course, with our specialist knowledge and products around these areas that we do. So it might be adhesive, it might be tightening, might be vision systems, and so on. And then we collaborate with other suppliers of other technologies and these machine tool builders to make the best assembly line possible, and of course the end customer as well. I would say one of the key areas there where I'm also where a lot of my work is of course around connecting things and so on. And here I think there's been a lot of progress over the last years with more standard protocols such as OPC UA, etc., where it's now easier than ever for machines to talk to machines, which is really what you need in the modern assembly line, right? You want to have very close where you can connect the cables, do it very, very easily, and things start working. And I think I've seen over the last few years really big strides forward in that, making things much easier to get up and working together when it comes to the machines.
What are the future developments in assembly technology that you see, Per, and how will they impact the industry and the society?
So right now we see that there's a change in the assembly line going on. So maybe we can talk about the current way of manufacturing. So you start with a stamping process. So these metallic components are stamped. Then you have the body shop, so the components are joined together using adhesive or mechanical joining technology. Then you have the coating, and afterwards you have the painting process. And for example, then it is necessary to disassembly, for example, the doors of a car. Then you put in all the interior equipment, like the seats, and then you start to have the final assembly and the final product. And there's a new way of manufacturing. It's called the inside-out process. So you start for sure with the stamping process, but afterwards you have directly this painting process. So you have pre-painted parts. And we also mentioned this mega and giga casting. So you put these painted parts together with those large-scale castings. And then it's possible to have a sub-assembly, so it's so-called modules, and at the end you put those modules together. And this has a big advantage because it improves efficiency. More persons can work on one car at the same time. And for example, you have the battery tray, and on this battery tray you assemble the seats and the interior equipment, and then you put the car together. And the big impact is that you have a much shorter assembly line, and therefore you have a higher efficiency and lower cost. But this has an impact on our joining technologies, on the materials used, and also on the paint. And therefore we have to adapt and improve our processes to this new way of manufacturing. And there's one additional point really important. We talked a lot about joining technologies, but I think it's really important also to consider how to disassembly those cars. So it's really important how to get the modules out of our battery, and also how to disassembly a body of a modern car, because this is really crucial and important in terms of sustainability and in terms of recycle and reuse.
And I guess this is the same for all products, right? You want to disassemble mobile phones or to reuse parts for that as well. So it's not only for the car industry, right?
What I see coming forward in innovation, I would say, first of all, I think the manufacturing industry overall right now is in one of these kind of disruptive phases, where it was stable for a while, and now it's in one of these disruptive phases with new technology. And I don't mean disruptive in a negative sense right now. I mean it in the positive sense. There's so many possibilities, opportunities being opened up with technologies like the AI coming, with automation taking great leaps and so on. So I think it's not too far in the future, but looking at further more robots on the line is for sure there. I think some companies right now are trying to get like robots that look like people or dogs and so on there. And in this, right, sometimes it came from being a couple of years ago, this was kind of science fiction, and now it's very close to being reality. So that's a little bit how fast the world moves right now. So it's almost dangerous to make predictions about the future, because it might be true in 6 months. It feels like a little bit, but it's really exciting times, I would say.
Yeah, and I think it was interesting because I had a colleague of yours here in my first show, Frida, and she talked about ergonomics for robots as well. So you use the things you have learned for humans, you actually apply for robots now as well.
Yeah.
The same technologies. So
Yeah.
that's quite cool.
Yeah, and as I said, it's not something that's coming in the future. It's already starting to happening now. I mean, one example is that we have one like trial application out at one customer where we have one of these robot dogs walking around with our vision system, and essentially what is like laser projection systems or projection system that walks around and helps workers to point out where they should look on the parts and so on. So it's it's moving fast.
Is there a reason for being dogs, or
I don't know why they picked that form factor, but it's interesting that it's people and animals that is the kind of form factor for the next generation of robots.
Yeah. That concludes today's episode on assembly technology. For more information, visit us at atlascopcogroup.com. In upcoming episodes, we will continue our exploration of various technologies that are essential for society to function seamlessly. Thank you to David, Per, and Robert, and to all of you who have been listening. Take care and see you soon.